Now that we've done coins, let's move on to dice. It says, consider rolling a six-sided dice for the following problem. Standard six-sided die for the following problem. It says, what is the sample space when rolling one die? Well, if it's a standard six-sided die, we could have any of the numbers 1, 2, 3, 4, 5, or 6. Now it says the table below will help us consider the outcome of rolling two die. Complete the table with each entry is the sum of the two die. So let me just make sure you understand this. If you call this die 1 and you call this die 2, the first one would be an example of rolling a 1 on the first die and a 1 on a second die. But that's not what I care about in this table. What I care about is what is it when I sum those two numbers together. If I sum those two numbers together, I would get a 2. Likewise, in the next one, it would be rolling a 1 on the first die and a 2 on the second die. When I sum those two numbers together, it would be the number 3. So what I'm actually asking for in this table is the sum of the die. This is going to be a problem that we consider many, many times. So go ahead and complete this table. What you'll notice is after you start a row, it just increases by 1 every single time. Continue all the way through and complete the table. So all of the blue numbers here are the numbers in which they are the sum of the two dies. It's called the pips on the die, if you remember that from a previous section. So this is the sum of the pips of the die. This is a very important table. When you look at this, this is huge in gambling. One of the games in gambling that you can sum the two die is called craps, and craps is one of the most popular games when you go to a casino. It involves summing the two die together, the pips on the two die. So here it says, consider rolling one standard 6 die for the following problems. Again, here we're only rolling one die. We just did 2, so I want you to step back. We're only rolling one die now. It says, determine that the probability of 4 is rolled. Well, remember, there's 1, 2, 3, 4, 5, 6. Those are my possible outcomes. So what's the probability that I roll a 4? Well, the probability of going a 4 is one of the 6 sides of the die. That's a simplified fraction. That's good. What's the probability of rolling a 7 in this? Well, a 7 can't happen. That's 0 times out of the 6 total possible. 0 divided by any number is 0. So what's the probability of rolling a 7 on the die? It's 0. Anytime you have a probability of zeros, it means it's not possible. It can't happen. Let's look at the next one. It says, what's the probability of an even number being rolled? Well, the probability of an even number of being rolled is the probability of getting a 2, 4, or a 6. Those are the even possibilities. So that is 3 of the 6 sides of the die. 2, 4, and 6 is 3 of the 6 total sides. Again, simplify that fraction and you end up with 1/2. Let's go on to the last one. It says, what's the probability that the number is between 1 and 6? The probability of between 1 and 6, well, that's all 6 of the 6 numbers. 6 divided by 6 is 1. So if a probability of 0 means it's not possible, a probability of 1 means it must occur. It has to happen. A probability of 1 is like a 100% chance that it occurs. Absolutely guaranteed. So if you roll a die, you are guaranteed to get a number between 1 and 6, which makes sense.